And there are two ways we make use of it. The first is in computing bounds. So you'd expect that because obviously we were computing some different bounds from metric FF somehow. This is how we're doing it. So metric FF bounds just say the maximum value of this layer is the maximum value at the previous layer plus the sum of all the producer's effects. And the minimum value at this layer is the minimum value at this layer minus the sum of all the consumer effects. But we have a slightly more complex way to calculate bounds that takes into account, uses our LP so we can take into account this resource transfer. So we construct the LP for layer I. Compute the bounds at layer I. Set the objective function to maximize some variable. And the value of this variable gives the upper bound of V at layer I. So we go back to our LP for fact layer 1. We say, right, this is your LP. These are your constraints. Maximize the value of M prime. This should be M prime. And then it tells us, well, the maximum value of M prime is 4, because you just set P to 0. And then we say, right, minimize M prime. And it says, well, the minimum value of M prime is 0. You do 4 produce actions. Because remember, we have a constraint here that all the variables are greater than or equal to 0. And we do that for all our variables. So the next variable is store. So we say, right, maximize the amount of stuff you've got at the store. And that tells us 2. And we say minimize it, and it tells us 0. And so on and so forth for all those variables. And this is how we get these bounds here at each layer. And then when we expand to layer 2, we do the same thing with this LP for layer 2. We say maximize M, maximize store, minimize store, and so on. And we just keep going, computing all the bounds all the way along here. So you'll notice here, we're solving a lot of LPs here. For each variable at each layer, we solve the LP twice. Once maximizing its value, once minimizing its value. That's quite a lot of LP solving. And a lot of people asked us when we first did this work, well, is that not going to be far too expensive? But empirically, because we've got very small LPs, we can manage to do it, and it does appear to be worth the trade-off. So that's basically an empirical answer to the question, which in theory you're solving a hard problem a lot of times, but in practice it's a small enough instance so we can get away with it.